Hello everyone. Today we will going to see some practice questions from the JEE. Let's examine some practice some previous year questions which have been covered in the previous year examinations for the JEE exam. Right? So let's start our today's topic, that is NCERT Chapter 2 Electrochemistry JEE PYQs Part 3. Disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of original creators and owners. If you are the owner and have any concern or issues, please contact us at sathi@iitk.ac.in and we shall remove the content immediately. Please note that the parts of content may have been generated using the generative AI, which is experimental. So let's begin with our first question, which is a JEE PYQ, and it is covering the NCERT section 2.3 from the chapter Electrochemistry in the NCERT textbook. Question is saying that for the following cell, we have given a representation of cell which is zinc sulfate and copper sulfate cell. So zinc sulfate, salt bridge, copper sulfate, copper. So this double line representing the salt bridge present in the cell. So for this representation of cell, when the concentration of zinc ions, zinc 2 positive ions, is 10 times the concentration of copper 2 positive ions, the expression for the delta G, that is free energy in the joules per mole units, is. So you have to tell the value or tell the expression for the delta G. F is given as Faraday's constant, R is taken as gas constant, and T is representing the temperature. Meanwhile, E naught of the cell is given as 1.1 volt. So, this question has been in the 2017 advanced examination, and the four options given for this question are 2.303 RT plus 1.1 F, 1.1 F, 2.303 RT minus 2.2 F, or minus 2.2 F. So you have to select the correct expression for expressing the delta G value for the given cell. You have given some time, try to solve it, and then we will see that which is the correct expression or which is the correct answer. Okay, let's see. So for this given question, the correct answer is option C, that is 2.303 RT minus 2.2 F. So let's see how. So the redox reaction for this question is zinc plus copper 2 positive, giving us zinc 2 positive plus copper. Right. So zinc, when reacting with the copper 2 positive ions, they are converting to zinc 2 positive ions and the copper. That means zinc is undergoing the oxidation process and copper is undergoing the reduction process. The Nernst equation for this cell reaction is E is equals to E naught. E is representing the overall potential of the cell. E naught is representing the standard potential of the cell, minus 2.303 RT by 2F log 10. Okay, so 2 is representing the N is basically the number of electrons which are interchanging between the oxidized and the reduced species in a reaction, in a cell reaction. As you can see that zinc is gaining 2 positive charge, that means zinc is losing 2 number of electrons to become zinc 2 positive. And similarly copper 2 positive gaining 2 electrons to become copper, that means 2 number of electron are interchanging between the oxidized and reduced species. So N we have taken here in the Nernst equation as 2, and rest of the thing are same. Log 10 is basically the we have taken the concentration already given, that the concentration of zinc 2 positive is 10 times the concentration of copper 2 positive. Here we have written log of product by reactant. Product is zinc 2 positive and reactant is copper 2 positive, because zinc and the copper in the neutral form are in solid form, so we don't take the solid reactant or product in this Nernst equation. We only consider here the aqueous or the liquid or the gaseous ions or atoms from the reaction. So only that is ions, which is zinc 2 positive or copper 2 positive. So product upon reactant means zinc 2 positive upon copper 2 positive. So here it is coming out as log of zinc 2 positive upon copper 2 positive. But in the question it is mentioned that the concentration of zinc 2 positive is 10 times the concentration of copper 2 positive. That means the concentration of copper 2 positive is equals to 10 times zinc 2 positive, right? So you can write it you can write that the concentration of uh, zinc 2 positive is 10 times the concentration of copper 2 positive. So you can write zinc 2 positive is equals to 10 times of copper 2 positive divided by copper 2 positive. Copper 2 positive will cancel out, only 10 will remain. That's why we are writing it here as log 10. You got it? So basically here comes out as log of product by reactant. Product is zinc and reactant is copper 2 plus ion. Zinc concentration is 10 times copper 2 positive concentration. That means you can write the concentration of zinc as 10 times copper 2 positive divided by the reactant is copper 2 positive. Now in the denominator and the numerator copper 2 positive are present, so they will cancel out, only 10 will remain, and hence we got this equation as Nernst equation for the cell reaction as E is equals to E naught minus 2.303 RT by 2F log 10. This is representing the NCRT equation 2.13. Now the E naught, the standard potential is already given in the question, which is 1.1. So 1.1 minus 2.303 RT by 2F, because log 10 is 1, because log in the base it is already 10. So when base and the value are same in the log term, then the value of the overall log will become 1. So log base 10 and 10. So log base 10, 10 is equals to 1. So that's why we multiply it by 1, and as it is will come here. So E, that is overall cell potential, will be equals to this much. Also we know that delta G, that is the free energy, is equals to NEF, right? This is the expression for the delta G. And if you put here the values, so N we have taken as 2, so 2 times F is a constant F, multiply by E is a term which we just have simplified, so E is equals to 1.1 minus 2.303 RT by 2F, right? This is the term we just have simplified. So minus 2F times E. Now we just cancel the common terms and try to simplify this equation more to get the perfect expression for the delta G. So this will become minus 2.2F when you multiply this 2F inside the bracket and take the LCM and cancel out whatever it can be cancelled. So minus 2.2F plus 2.303 RT, this will become, this equation will become equals to this. Delta G is equals to this much. And you can rearrange it and write the positive thing first. So 2.303 RT minus 2.2F. So this is correctly matching with our option C, and that is why this is the correct answer for this given question. Okay, let's move on to our next question. This is a JEE PYQ and this is covering the NCRT section 2.3 given in our NCRT textbook in the electrochemistry chapter. The question is saying that For the following electrochemical cell at 298 Kelvin temperature, this is electrochemical cell given at a particular temperature, which is platinum hydrogen, which is a gas at 1 bar pressure, H positive, which is aqueous in the aqueous medium having the concentration 1 molar, salt bridge M4 positive, which is again in an aqueous solution, M2 positive in aqueous solution, platinum. So the E, that is overall cell potential for this cell, is given as 0.092 volt when the concentration of M2 positive to the concentration of M4 positive is given as 10 to the power x. We have given that the standard electrode potential for M4 positive to M2 positive is equals to 0.151 volt, and also it is given that 2.303 RT by F, you can take this value as 0.059 volt. So you have to identify the value of X in this question. X is here in the ratio of the concentration of M2 positive to M4 positive. So you have to identify what is the value of X. This question has been in the 2016 advanced examination. The 4 options given are -2, -1, 1 or 2. So you have given some time, try to solve this, and then we will see that what will be the correct answer. Okay, let's see. So for this given question, the correct answer is option D, that is 2. So the value of X is 2. Let's see how. So let's see first of all the oxidation process which is happening at the anode in our cell, which is H2 is converting to 2H positive and also releasing 2 number of electrons in the aqueous medium. This is the oxidation process. Why? Because releasing of electron is happening, which is a basic definition of oxidation process which we are using in this chapter. So this is the oxidation process happening at the anode. Now E naught of SHE, this is a reaction for standard hydrogen electrode, and we know that the standard cell potential for standard hydrogen electrode is taken as 0 volt. Now at the cathode, the another electrode cathode, the reduction process is happening at there. So what is the process? It is that M4 positive, that is M in the 4 positive state, gaining 2 electrons or 2 negative charges and becoming M2 positive in the aqueous medium. So M4 positive to M2 positive reduction is happening. Also you can define it as the gaining of electron is happening. That means the reduction process is happening at the cathode. And the E naught for this is already given, which is 0.151 volt. Right? Already given that standard electrode potential of M4 positive to M2 positive conversion is given as 0.151 volt. So the net reaction will be M4 positive. We just for the net reaction, we add the two reactions which is happening at anode and the cathode respectively. So when you add these two reactions, these 2 number of electrons, one is present at the right hand side of this right arrow of the reaction, and the another 2 electron in the another reaction is present at the left hand side of the right arrow, right? So they will cancel out and the remaining term will add up. So M4 positive here plus H2, this will give you 2H positive and M2 positive. So whatever there was be at the left hand side of the right arrow, after the adding of the two reactions of oxidation and reduction, they will as it is be added up at the and placed at the left hand side of the right arrow, and similarly the right hand side thing will add up together and placed at the right hand side of the right arrow in the net reaction. So that's why we have written M4 positive plus H2 at the left hand side plus this will giving us M2 positive plus 2H positive at the right hand side. So this is the net reaction happening in our cell. the K, if you find out, they will be it will be M2 positive concentration times H positive concentration whole square. Why we are taking both? Product by reactant, right? And here nobody, like not even in the reactant or in the product, anything is in solid form, so everything will be considered. So M2 positive times H positive whole square, because the stoichiometric coefficient is taken as 2, divided by M4 positive concentration multiplied by pressure of H2 gas. Okay, for the standard hydrogen electrode, we consider the hydrogen pressure other than its concentration. So this will be the K equation, and it is already given that concentration of H positive ions in the cell representation, it is mentioned that it is 1 molar. The H positive is 1 molar and the H2 pressure is given as 1 bar. So this H positive is become 1, pressure of H2 will become 1. So the remaining term will be M2 positive concentration divided by M4 positive concentration, and this ratio is already given as equals to 10 to the power x. So this ratio is equals to K for this net reaction. Now for the Nernst equation, which is overall cell potential is equals to standard cell potential minus 0.059 by 2 log K. This is the Nernst equation we are using for the given cell representation, and this is marked as NCERT equation 2.12 in our NCERT textbook. We are taking 2.303 RT by F as 0.059 volt. Already it is mentioned in the question, and divided by N will remain. N we are taking as 2, because in the M4 positive to M2 positive or M2 positive to M4 positive, 2 electrons are adding or subtracting from the reduced or the oxidized species, right? That means 2 electrons are involving. That's why we are taking N is equals to 2. This is the Nernst equation. Now we put the values. So overall cell potential is given as 0.092 in volt in the question already. So we put the value 0.092 is equals to E naught of cell, which is given as 0.151 minus the E naught of cell we considered for the M electrode, because the another electrode is standard hydrogen electrode whose E naught is 0. So E naught of cell will become 0.151. Okay, what if we are not taking here the standard hydrogen electrode? Then its E naught will also be considered here in the E naught of the cell, and that you will calculate by E naught of cell is equals to E naught of cathode minus anode, or anode minus cathode, I don't know, but something like that, right? You have to subtract the E naught value of 2 electrodes, then you will get the E naught of cell, and you are getting it right exactly the same. Cathode minus anode is the equation. So cathode 1 having E naught value 0.151, anode 1 having 0. So this minus 0 will be this one. So that's why we are writing E naught of cell is equals to 0.151 minus 0.059 by 2 log of the K value we just derive, which is M2 positive upon M4 positive concentration. In this, if you see, only this ratio of log is only the variable whose value is already given as 10 to the power x. So we put that value here in the log term. So 0.059, this when you subtract by interchanging the terms from to and also making them positive, they will become 0.059 is equals to 0.059 by 2 log of this ratio will be 10 to the power x. Okay, now we use here the log property, which says that log base 10 m to the power n is equals to n multiplied by log base 10 m. Okay, if something is in the power of log, they will come in the multiplication if we are talking about log base 10. This is the property of the log. So we apply it here, and rest of the term we want to simplify. So log base 10 and 10x. Log 10x is equals to coming out as 2, because it's 0.59, 0.59 cancel out. This 2 will go here. So log 10 to the power x is equals to 2. And therefore, you can write it as log base 10 10 to the power x. This will become x multiplied by log base 10 10, and log base 10 10 will become equal to 1. Log 10 is 1. Okay, so x multiplied by 1 is equals to 2. That means x is equals to 2. Okay, so that's why x is equals to 2 is our correct answer. The value of x is coming out as 2. Okay, moving on to our next question. This question is a JEE-PYQ, and this is covering the NCRT section 2.3 in the chapter Electrochemistry. The question is saying that consider the following cell reaction. We have given the cell reaction: 2Fe plus O2 plus 4H positive converting to 2Fe2 plus 2 molecules of water. The E naught for this cell reaction is given as positive 1.67 volt. Now, when the Fe2 positive ion concentration is 10 to the power minus 3 molar and the pressure of the oxygen gas is 0.1 atmosphere and the pH of the solution is given as 3, the cell potential at 25 degrees Celsius is. So, you have to tell the value of cell potential in this question. Okay, given these amounts of concentration of iron 2 positive and the pressure of oxygen gas and the pH of the solution. So the four options given are 1.47 volt, 1.77 volt, 1.87 volt, or 1.57 volt. So you have some time to solve this, to try this, and then we will continue to its correct answer. Okay, let's see. So for this given question, the correct answer is option D, that is 1.57 volt. So given the cell reaction, which is 2Fe plus oxygen plus 4 protons, giving us 2Fe2 positive plus 2 molecules of water. This is the cell reaction already given in the question. Now, E naught of this is given as 1.67 volt, and Fe2 positive ionic concentration is given as 10 to the power minus 3 molar to consider, and the pressure of O2 is we have to take as 0.1 atmosphere. The pH of the solution is given as 3, and then H positive concentration will become equals to 10 to the power minus 3. This is we conclude from the pH formula. pH is equals to minus logarithm of H positive concentration. So from that, if pH is 3, H positive concentration is 10 to the power minus 3 molar. Temperature we have to consider is 25 degrees Celsius. You have to convert it into the kelvins by adding 273 into the Celsius, which is a standard conversion of the Celsius to the Kelvin. So it will become 298 Kelvin. And you can take 2.303 RT by F equivalent to the 0.059 volt, which we generally consider to simplify our calculations. Now the next equation for the given cell will be E of cell potential, overall potential of the cell is equals to standard cell potential minus 0.059 by N log Q. N here we should take 4 because that is the number of electrons exchanged, N equals to 4. Now for the reaction, 2Fe plus O2 plus 4H positive converting to 2Fe2 plus 2 molecules of water. Solids and pure liquids are omitted from the Q. Okay, so Q is the reaction quotient. We doesn't consider here the reactant or the products which are solid or are pure liquid. So we don't consider that. Q will become then Fe2 positive whole square from the reaction. Okay, from this reaction, Fe2 positive 2 whole square, because 2 is present as a stoichiometric coefficient, which will go in the power of the concentration of Fe2 positive. So Fe2 positive whole square divided by the reactant. Reactant in the aqueous form is given as H positive. 4 is stoichiometric coefficient, go in the power. So H positive power 4 multiply by the pressure of the oxygen gas. Iron is in the solid form, it will not consider in the Q, and also liquid, pure liquid will also not considered in the Q. So the Q value is given as Fe2 positive whole square divided by H positive concentration whole 4 multiply by pressure of the O2, that is oxygen gas. Simply now you have to solve the Q value. So Fe2 positive concentration is given as 10 to the power minus 3 molar. So 10 to the power minus 3 whole square divided by H positive concentration, which is 10 to the power minus 3 whole 4. Okay, why we are taking H positive concentration as 10 to the power minus 3? Because pH is given as 3 from the formula of the pH and the value of the pH given. We simplify that H positive concentration is 10 to the power minus 3. Multiply by the pressure of O2. Pressure of O2 is given as 0.1 atmosphere. So we multiply it by 0.1. Now you just have to solve this. So this will, numerator will become 10 to the power minus 6 divided by 3 times 4 will be 12. So this will become 10 to the power minus 12 multiplied by 0.1. Now we more simplify it. It will become 10 to the power minus 6 upon 10 to the power minus 13, because 0.1 is 10 to the power minus 1. And minus 12 and minus 1 will be minus 13. So that's why 10 to the power minus 13. When you divide this, this will be 10 to the power 7. How? This 10 to the power minus 13 will go in the numerator and become plus 13. So plus 13 and minus 6. Bases are same, 10 and 10. So power will get summed or subtracted. So minus 6 and plus 13 will be subtracted, right? 13 minus 6 will be 7. So that's why the answer is 10 to the power 7. So Q value we just derived as 10 to the power 7. Now we put the Q value and the rest of the values in the Nernst equation. So overall cell potential is equals to the standard cell potential, which is 1.67 volt. So 1.67 minus 0.059 by n is 4. We have to consider as 4. Log of Q is 10 to the power 7. Now again we apply here the log property, that log 10 7 is 7 multiplied by log 10, and then log 10 will become 1. So this will become 1.67 minus 0.059 by 4 multiplied by 7. You just have to now solve this. So 1.67 minus 0.01475 multiplied by 7. This is equals to overall potential of cell. And then when you more simplify it, it will be 1.67 minus 0.10325. This will be equals to 1.56675 volt. So this is the overall cell potential value for the given cell. Okay, hence this will be the answer. Okay, moving on to our next question. Okay, so this is a JEE PYQ and it is covering the NCERT section 2.3. The question is given as zinc 2 positive, the A, that is concentration is 0.1 molar, salt bridge Fe2 positive whose concentration is 0.01 molar to Fe. This is a cell representation. The EMF of the above cell is 0.2905 volt. So the EMF for this cell is given as 0.2905 volt. The equilibrium constant for the cell reaction is, you have to find out the equilibrium constant for this cell reaction. So the options given for this question are 10 to the power 0.32 divided by 0.059, 10 to the power 0.32 divided by 0.0295, 10 to the power 0.26 divided by 0.0295, or 10 to the power 0.32 divided by 0.295. So you have given some time. Okay, try to solve this and then we will see that what will be the correct answer. Okay, let's see. So for this given question, the correct answer is option B, that is 10 to the power 0.32 divided by 0.0295. So the cell reaction for the given cell representation is zinc plus iron 2 positive converting to zinc 2 positive plus iron. So iron is undergoing reduction process and the zinc is undergoing the oxidation process. The cell potential is given as 0.2905 volt for the cell reaction. The next equation will be E equals to E naught minus 0.059 by 2. 2 is N. So N, that means the number of electrons contributing in the redox section is 2. So that's why N equals to 2 here. Log of product by reactant, product zinc 2 positive upon reactant Fe2 positive. Other than that, the neutral iron and the zinc are in solid form, so we don't consider that in the product and the reactant. So E naught minus 0.059 by 2 log of zinc 2 positive upon Fe2 positive concentration. Now E naught will be, you take whole this quantity to the left hand side, they will become positive. So E naught will be 0.2905, the overall cell potential value, plus this whole term. We put the zinc 2 positive concentration as 0.1, already given in the question, and Fe2 positive concentration as 0.01, it is already given in the question. Now when you solve this, E naught is coming out as 0.32 volt. We also know that E naught is equals to 0.059 by n log k, okay, at the equilibrium. So we have to find out the equilibrium constant. So when you consider the equilibrium condition, the E will become 0 for the reaction, right? And the E naught will become then equals to 0.059 by n log of k, log of equilibrium constant. So log of k here will be n go here. So n is 2, 2 times E naught, 0.059 go in the denominator. And when you solve this, this will be 0.32 upon 0.0295. Okay, now log k is equals to this much. So k will be 10 to the power this whole quantity. Okay, why we didn't multiply 2 by the E naught value, which is 0.32, because in the options we have given in the terms of 0.32 in the numerator in the power of the 10, right? That's why we have to keep 0.32 in the numerator. That's why we divide this given quantity in the denominator by 2, and rest E naught will be there in the numerator, that is 0.32. Right? So k will be, log k is this fraction, so k will be 10 to the power of this fraction, 0.32 upon 0.0295. Hence, the correct answer is option B. Okay, moving on to our next question. Now, this is a JEE PYQ and this is covering the NCERT section 2.2. Question is saying that saturated solution of KNO3 is used to make the salt bridge. Because the reason you have to tell, okay, that why we use the saturated solution of KNO3 to make the salt bridge in the cell. Options are: velocity of K positive is greater than that of NO3 negative. Velocities of both K positive and NO3 negative are nearly the same. KNO3 is highly soluble in water. So you have to tell that which is the correct reason for using the saturated solution of KNO3 to make the salt bridge. You have given some time, try to solve this, and then we will see that which is the correct answer. Okay, let's see. So for this given question, the correct answer is option C, that is velocities of both the K positive ion and NO3 negative ion are nearly the same. So one of the requirement for the electrolyte which is used in the salt bridge. So in the salt bridge, basically salt bridge we use in the cell for maintaining the electrical neutrality among the different solutions which are connected via salt bridge. So the requirement for the electrolyte which is going to be used in the salt bridges, one of the requirement is that both the cations and anions must have comparable size so that they migrate towards the electrodes of opposite polarity at nearly same speeds, comparable speeds, right? To maintaining the neutrality. So this is one of the requirement of the electrolyte which we are going to use in the salt bridge. So that is why the correct reason that we use the saturated solution of KNO3 to make the salt bridges, that velocities of the ions we get from KNO3, which is K positive and NO3 negative, are nearly the same. Hence, we have the correct answer as option C. Okay. Okay. Thank you so much.